Welcome to Kettle Labs How to series. Today, we'll demonstrate how to utilize Knowledge Graph in Advanced RAG. Let's get started. A knowledge graph in NLP is a structured representation connecting entities such as people, places, concepts through relationships, enabling machines to understand and reason about these connections. It supports tasks like semantic search, information retrieval, and question answering, using techniques such as entity recognition, relation extraction, and graph databases. Let's check this simple flow to understand how it works. The process starts with a user submitting a query. This initiates the RAG pipeline. The query undergoes several stages, such as query preprocessing, which formats and refines the query for efficient processing. Candidate retrieval fetches relevant documents, databases, or data points using advanced search techniques. Knowledge graph integration enriches the retrieved data with contextual knowledge from the graph. Contextual expansion augments the query with additional details derived from the graph and data sources. Generation module combines everything to generate a coherent and accurate response. These stages are supported by multiple data sources, such as SQL and NoSQL databases for structured and unstructured data, and document repositories for reference materials, and API for dynamic, real-time information. The knowledge graph plays a central role here. It's built through the ingestion of raw data, ontology mapping to define relationships. Triple Store serves as graph database for efficient querying. The knowledge graph ensures that the data is meaningful and contextual by enabling query refinement that iteratively improves the query results. Integration feeds enriched insights back into the pipeline. Finally, the RAG system generates a response, which is delivered back to the user, closing the loop. In this demonstration, let's start by preparing the Neo4j instance. Here we clear all existing data and reconnect to the Neo4j database, ensuring a fresh start. Now, let's move to the code. First, we install the necessary libraries, such as LangChain, Neo4j, and others, to connect to the Neo4j graph and work with a language model. Next, we set up the connection to Neo4j using LangChain's Neo4j graph class. We load a movie dataset into the graph, which includes details such as movies, directors, actors, and genres. Here's how we load the dataset and execute the query. Avatar continues, and we refresh the schema to ensure everything is set up correctly. Now, let's access the environment variables. We use the Grok API key from our end file to set up the Chat Grok language model, which interacts with our Neo4j graph. Next, we set up the query function to interact with our graph. Using the graph cipher QA-chain, we fetch data based on the user's question, such as finding the actor with the highest number of movies. The code generates a neat table, displaying results including the actor with the highest number of movies. Neo4j visualizes datasets with nodes representing movies, actors, and genres interconnected by relationships. Its interactive browser simplifies understanding data structure. Let's execute another query. This time, we'll ask, how many artists are there in the graph? The system processes the question and returns the result. After querying the graph, we return to Neo4j to visualize the result. This helps us see how the nodes and relationships dynamically update as new information is retrieved. Stay tuned for more tutorials on Gen AI. Thank you for watching.